Imagine a colossal surge of electricity, enough to power the entire national grid of Ireland. What's even more shocking is that all that energy is compressed into a single transmission line, traveling across a vast, desolate desert for over 3,284 kilometers. This isn't a scene from a movie. It's a 1.1 million volt voltage monster that is changing the history of human energy transmission forever. Today, we're diving deep into the world of UHVDC, ultra-high voltage direct current, the technology set to become the new backbone of the clean energy era. We are facing what engineers call geographical paradox. The problem is that the world's most abundant clean energy sources are often hidden in uninhabited places, scorching deserts or wind-swept plains. Conversely, the major economic hubs and residential cities are thousands of kilometers away. For a century, we've relied on alternating current, AC, as our primary workhorse. But for ultra-long distances, AC reveals a fatal flaw. Energy gradually evaporates into the air as heat. The further it travels, the more hard-earned energy is wasted. This physical limit has long blocked our full access to clean energy. Enter our new hero, UHVDC. Think of it this way. If AC transmission is like cycling through thick mud, UHVDC is a high-speed maglev train gliding for 10,000 miles with almost zero friction. It clearly outperforms AC at distances over 700 kilometers for overhead lines and just 70 kilometers for subsea cables. This technology works by converting AC to DC at a staggering 1.1 million volts, the highest in history. By boosting the voltage this high, we can slash the electrical current, which drastically reduces heat and transmission loss. Today, we can transport massive amounts of power over 3,000 kilometers with only minimal energy loss. This success didn't come easy. The engineering behind this million-volt beast is a logistical nightmare. Imagine transporting a 40-meter-long transformer weighing hundreds of tons across steep mountains and rugged terrain. Every component is designed for the impossible, from giant transformers to converter valves that must withstand voltages ready to leap across insulators at any moment. Furthermore, in sandstorm-prone deserts, engineers must build indoor DC yards to shield the heart of the system from pollution and extreme weather. The final piece, the holy grail of the power industry, is the hybrid DC circuit breaker. In the past, cutting high-voltage DC was harder than extinguishing a blast furnace. Unlike AC, DC has no zero crossing point, creating massive destructive arcs when disconnected. Today, global tech leaders like ABB and Siemens have developed innovations that can trip 10,000 amps in mere milliseconds, 10 times faster than a human blink. This is the ultimate safety net for a stable and secure smart grid. In this battlefield, China is surging ahead, building a great wall of electrons. They've invested over $88 billion into 13 UHVDC lines, while Europe and America still face hurdles like land rights, complex regulations, and social resistance. China views clean energy as the most critical infrastructure of the 21st century, reshaping both their economy and geopolitics. But as strategists, we must look deeper. Most people admire the hardware, but no one asks, is sending power across continents actually a failure of urban planning? Why can't we produce energy where it's consumed? And if energy storage tech evolves so everyone can generate cheap power at home, will these trillion-dollar lines become useless monuments? This is the high-stakes bet global organizations and investors must solve. However, the next step for UHVDC goes beyond wires and transformers. It's the fusion with AI and big data to create a digital central nervous system. This intelligent system predicts weather second by second to manage the volatility of wind and sun. It is an invisible dance of millions of electrons, perfectly organized to power your homes and factories without fail. Ultimately, the world's future may not depend on how well we build solar panels or how large our wind farms are, but how efficiently and smartly we can move those electrons across continents. In a world where energy is everything, those who master UHVDC and smart grids will hold the power to drive humanity into a new century. This isn't just electrical engineering, it's about sustainability, security, and a future we must all help decide. Don't just watch the change happen. Think, plan, and build a world of clean, equitable energy for everyone.